Okay, before I move on to any more examples, I want to just do a little bit of a summary of the relationship between a function and its inverse. And I hope that these videos are a learning experience for you guys. I hope you're not missing my face too much and that you're not falling asleep. So here we go. So if we have f of x, its inverse would be called f inverse of x, and sometimes we just call it g of x. But most of the time it's the inverse function. So if we have a point on f of x, so let's call our point a comma b, then its inverse point on the inverse function would be b comma a. So for example, if we had f of 3 equals 2, that would actually be the point 3 comma 2. So similarly, the point on the inverse would be 2 comma 3, and how you would write it in function notation would be f inverse of 2 would equal 3. Okay, so to continue again, if we have f of x and its inverse function, if we have a slope here, which is our derivative, so our derivative is the same thing as our slope, right? To find the derivative of the inverse, all you had to do was f negative 1 prime of x, remember this is the prime, this is the derivative inverse, would equal 1 over f prime of y. And again, that y comes from the new inverse function's y. So similarly, it's really just the reciprocal of m. So the derivative of our inverse here is actually just equal to the reciprocal. And we haven't talked about that too much, but I wanted to summarize it now. So again, if our slope for our function is m, then the slope for our inverse is just the reciprocal. Okay. So a couple more examples. If we have f of x and its inverse, okay, and we had a point that lied on f of x, like 3 comma 4. The point on here would be 4 comma 3. Let's say that, let's put it in function notation. So f of 3 equals 4. Function notation over here would be f inverse of 4 would equal 3. Now let's, for example, say that the derivative, again, this is just an example. Where am I getting this? I'm making it up, but we're seeing how the two inverses are related. Okay? So let's say that f prime of 3, that's the slope, okay, is equal to negative 10. Then here you would say that f inverse, its derivative, okay, would be the reciprocal of that one. So it would be 1 over negative 10. It's not the opposite reciprocal, it's just the reciprocal. Now, I left this part intentionally blank because this is the part that people get confused on. Should it stay 3? The answer is no. Remember, we want to match up our points. So here, this would just go back and again stay the number 4. All right? Everybody see the relationship there? Maybe, I hope, I'm praying. Okay. Okay, so here's another example I want you guys to try. I'm going to give you some time. I'm not really sure how much time. Maybe you just want to ask the sub to pause the video. But for this first example, that would be this first box. If this is your function, this is the point, what would it look like here? If this is the slope, right? What would the slope of the inverse look like? How would you guys fill those blanks in? Okay, go ahead and do number 2. G of 3 equals 1. Again, this is a point. And it's not writing. Okay, it's a point. What would it look like for its inverse function? Now, you can call the inverse f, you can call the inverse g to the negative 1, or you can just call it g inverse. Okay, but this is the slope. How would you change its slope? Okay, and then the last example is down here. It gives you again a point and then a slope. So I'm going to give you guys about a minute. Maybe you'll just want her to pause it for a second or two. Okay, So now that you are back from being paused, this is what the answers look like. Okay, so I'm back from being paused. These are the answers to your right-hand side in the lighter colored white. Again, the inverse, you would switch A and B, the point. For the derivative of the inverse, okay, remember, you have to switch these x values, and then this is just the reciprocal of 1/2. It's not negative reciprocal or opposite reciprocal, just the reciprocal. Okay, and this is different than being normal line, right? Okay, second example, you switch the x and the y, or you switch the A and the B. This one here, again, make sure you switch this x value, but what's the reciprocal of 0? Well, it is undefined. And then the last one, again, you switch the point, and then don't forget to do the reciprocal. Again, I really want to make sure that I point this out, but here and here, those do not stay the same. All right, there's still a lot that we can go over and that we will go over, but I think this is enough to get you guys started. I hope you were able to take notes. I want you to try for classwork 11, page 11C in the packet, numbers 2 through 9. You can ask the sub to go back in the video, or you can again watch the video at home. I'm going to go ahead and send this link to everybody, and hopefully, it helped you guys get started on the derivative of the inverse. All right, so I'll see you tomorrow. I'll have some news about the test, especially since we didn't get to finish it all together. All right?